I'm back here at the Cosmic Streams in the Age of Rubin Observatory Conference in Puerto Varas, Chile, on a Friday, the end of the conference, and I've just spoken with Matthew Graham for an interview, and we touched on some interesting points. Matthew is a professor of astronomy at Caltech, and you're also the project scientist for the ZTF project at the Palomar Observatory, using a 1948 era telescope, correct?
That's right.
So tell us, just give us a brief description of ZTF, why it's a stepping stone for the LSST Vera Rubin Observatory, and then let's talk about the future of AI.
Okay. So ZTF is a sky survey that's been running for 5.5 years at Palomar, as you said, on the 48-inch telescope, which is, was originally constructed and started operations in 1948, it originally was designed to be, it's a survey telescope, and it originally held photographic plates in the focal plane, and then in the early 2000s that was replaced by sort of first generation CCD cameras, and ZTF is the latest iteration in that cycle, but it fills the entire focal plane of the telescope with CCDs, so you get a field of view of 47 square degrees covered by the ZTF camera.
And a CCD, for the readers who don't know, is what?
CCD is the piece of technology you probably have in an old cell phone camera or an old digital camera. They've been replaced by CMOS detectors, which are the next generation in that technology. But the advantage of this is it's the camera which has the largest digital field of view at that depth for survey telescopes currently in the world. So it can go deeper and wider than other. There are telescopes with smaller systems. There are bigger telescopes with smaller fields of view. So ZTF occupies this really sweet spot in what it has. Rubin is the sort of successor to ZTF. It'll have a smaller field of view, but it goes much deeper, and that's a 8-meter telescope as opposed to a 1.3-meter telescope.
And ZTF stands for what?
ZTF stands for the Zwicky Transient Facility. So it's named after Fritz Zwicky, who is the sort of founder of sky surveys. He's the one who started the sky survey program at Palomar Observatory 75 years ago.
And you actually, ZTF has been in operation since 2018.
Yeah.
And it will probably likely disappear once.
So we have current funding to the end of 2024, early 2025. We're always looking for more funding to keep it going, because we know that the longer sets of time series we can have, the longer baselines in our light curves, the better for all sorts of science. But it's a fixed market. There are only so many experiments that can be run, and LSST will start its operations in 2025, and that's a much bigger program than ZTF, and so there maybe is a natural transition point in community science from ZTF to Rubin, even though they could complement each other very well if we had lots of money.
So two things. One, we know it's going to be an embarrassment of riches that we won't be able, when you have 10 million alerts a night, we're not going to be able to follow up on all those alerts.
No.
And, but the LSST, in the strict sense of the word, is not using artificial intelligence or AI.
No.
But talk about the experience when you first were a postdoc analyzing the sky survey, and how things have changed in the 20 or 30 years you've been in the science.
So I started my PhD just over 30 years ago, and I was dealing with photographic plates that were taken in Australia. They were shipped back to the UK, which is where I did my PhD. They were scanned, digitally scanned by an early form of digital scanner, onto a big magnetic tape, which was sent through the post to me, and then I had to load it onto a computer which had a 1.5 gigabyte hard drive. And that used to take about 2 hours to do the data loading as well. So these days I could do all of that on my cell phone over the internet, and it has more power, computing power, and whatever. So in 30 years, we've come a huge way in terms of just the computing power we have available to us, and that has allowed us now to come up with these. 30 years ago we would never have dreamt. There's no way we could have conceived of anything like LSST or even ZTF in terms of the data rates and the sampling rates and what they're going to do. But we have the computational power now. It's going to be tough, but we have the computational power now to do that. And so that's really exciting.
But there's some controversy at this conference about the use of the terminology artificial intelligence. There's some resistance.
Yeah, so I mean, it's not artificial intelligence in the sort of stuff that ChatGPT has been capturing, and where people are thinking we're going to have thinking computers. The types of things that we talk about this is why we use the phrase either machine learning or deep learning. There are some very, very complicated mathematical or very complicated data analysis techniques that we can't do. And just because the data is too large and the computations take too long, that we train the computers to do, so they do learn how to find rare objects or what a particular type of astronomical source looks like, so they can do that. But they're essentially following a rule set. They've learned a rule set themselves to optimize something that we've told them to optimize. And so there's no creativity coming from the computer. So it's not true artificial intelligence. And they're not making decisions. They're not making decisions that we haven't told them to make.
But the future of astronomy, professional astronomy, lies in artificial intelligence.
Yes, I think so.
And so describe what you were telling me.
Yeah, so I gave this talk around 2009 about what I thought astronomy in 2020 would look like, and we're not there yet. But I think the idea is that, in the same way that you wake up in the morning and today you may say, Alexa, what are the news headlines, or Siri, tell me what the weather is today, I could imagine waking up and saying, what did we discover last night on the telescope? And the system will say, well, I discovered this, and let me explain to you what I did. And it's not just telling me the rule set is followed, it will have made decisions on its own about what to do and what follow-up observations to take, and it'll come up with a physical explanation based on what it thinks it has found. So there will be an element of creativity. So that may be 2030, that may be 2040, but I think we're going to end up in that sort of scenario.
It's inevitable, isn't it?
Yeah, I think so. Yeah, it has to be.
Well, thank you so much, Matthew Graham of Caltech. We look forward to the results of next year and the years after with the LSST and Rubin. And thank you for taking the time to give us a little bit of insight about AI and astronomy.
That's fine.